Hello, my dear students. Welcome to the course of telecommunication and switching systems. Here is the first lecture of this course, and we will learn about the telephone networks. So, in telecommunication switching systems, you have to know clearly about the telephone networks. So, let us begin with this telephone networking. uh, there are some concepts regarding these telecommunication switching systems. That is, the telecommunication means that could communicate at a distance. Tele in Greek means at a distance, and the electrical communications by we can done by the wire, radio, or light. It is fiber optics. Traditionally, two distinct disciplines switching that selects and directs communication signals to a specific user or a group of users, and transmission delivers the signal in some way from source to the far end user with an acceptable signal quality. And that is the simple transmission system. So here you can see that there is a source, and there's a transmission media, and there's a destination. Very simple transmission system. A source may be simple telephone, microphone, keyboard, etc., and the destination may be simple telephone, speaker, monitor, etc. And now that is the that it can be seen as a single electrical medium. First of all, we get that is very simple type of transmission systems, but if we want to see the electrical medium, it can be seen as a single electrical medium. You can see that's the source, there's the medium, the destination that we seen before. But if we just elaborate this, there may be many mediums right there, not a single medium, because when we read about the networking and television network, so there will be a lot of cascading electrical media that has been incorporated in these telecommunication switching systems. And the networks show a gain or loss. To understand these gains or loss, a good knowledge of the decibel and related measurement units is needed. So that's a very important thing. So what is the decibel in communications? As we know, the decibel is a relative unit of measurement commonly used in communications for providing a reference for input and output levels. That means the power and or gain or loss, that we can measure the power, gain or loss by the decibel. And decibels are used to specify measured and calculated values in audio systems, microwave system gain calculations, satellite system link budget analysis, antenna power gain, light budget calculations, and in many other communication systems measurements. In each case, the decibel value is calculated with respect to standard or specified reference. Now, how you could calculate the decibel? The decibel value is calculated by taking the log of the ratio that is measured and calculated power P2 with respect to a reference power P1. So it will be the received power divided by the reference power. That means the input power, output by input. There is a simple logic behind this. And the result is multiplied by 10 to obtain the value in decibel. And it can be modified to provide a decibel value based on the ratio of two voltages. By using the power relationship P is equal to V square by R, we can use this kind of thing, that how we can provide the decibel value with respect to voltage. Just put the value here, P is equal to V square by R here, and just now we can calculate with respect to the voltage. So if we know the input voltage and output voltage of a telecommunication system, we can easily find out the power in decibel by this equation, 20 log 10 V2 by V1. And that's the received voltage divided by the as you can say, that is the received voltage divided by the input voltage. And the definition of dBm and dBw, that is a very much important thing, why we use the dBm. As we know, the decibel is very large scale, so sometimes there are some milliwatt range power that we should which we can measure. Decibel, the dBm means, that means the millidecibels. That indicates the specified decibel is related to a 1 milliwatt reference. If we take the power reference as 1 milliwatt, that is the important factor. If we take it to a 1 milliwatt reference, then we can say it will be a dBm unit. The dBm unit can be specified by that. As you can see, here is the power reference has been taken as 1 milliwatt. If power is expressed in watts instead of milliwatts, the decibel unit is obtained with respect to 1 watt, and decibel values are expressed as dBW. What is dBW? That is the with respect to the 1 watt. If we take just 1 watt, that will be dBW. That means decibel with respect to 1 watt. But decibel with respect to 1 watt is a very big scale. Sometimes milliwatt is far more enough to have a good communication. So we need to think about it. So there are comparative examples that how we can use the power levels to find out the decibel. So the logarithm of a power ratio are not a unit of power. However, dB watt and decibel meter are units of power in the logarithmic system of numbers. So you can convert the following into dBm to dBW. So if you know that your input power is 1 milliwatt, how you can calculate for the dBm? So there are particular equations that has been initiated and also defined in the previous lectures, then we can easily find out this. So that is one of the thing. Now, so there is a decibel hint that how you could find out the decibel. So if you want to find out the decibel value, there is a simple math that has been done for a networking system. So there is a 2 milliwatt of input in this network, and the output is 4 milliwatt. So that will be output by input, as you know, for the power level, that is 10 log 10 4 by 2. After that, you get the simplicity that you can get when you get the double power, that is 3 decibel of shift is created here. As you can see here, if you just calculate it, you can get the 3 decibel point. So that to memorize the above relationship, the amplifying network has a 3 decibel gain. So it is the network that has a gain of 3 decibels. So it is an amplifying network because the output power was a double the input power. So when you get the 3 decibel shift or 3 decibel power, it indicates the double power in this network, or it will be amplifying with the double power. So what will be done in the decibel power? What is the importance of that in the telephony? So the telephone is connected to public switch telecommunication network. So if you think about the total GPRS system and the the telecommunication network system, so there is a part that is known as the PSTN. Okay, so GSM system network, it also has the same thing. So it is the backbone of the network. That is the PSTN system. It is a public switch telecommunication network for local, national and international voice communications. So it is a large backbone system that has been spread over from local to international. The same connections can carry data and image information as far as we know from the television. The connection to the PSTN may be via local exchange carriers, LEC. Some local exchange carriers are situated in the streets and all other parts. Now they are found in the underground cable connections, and there are some end users, nodes and connectivities. So it's also a part of the telephony system. So what is the voice telephony? It's one of the most popular part in the telecommunication engineering. So voice telephony is the transmission of the human voice. That voice is a sound signal. We have to just modulate it and spread it through the telecommunication network systems. So there is a basic speech energy. As you can see, there is 25 decibel up to 25 decibel. There is some emotional other things that the speech energies may be up and down, and they are spreading towards the 500 Hz to 3500 and more or less any of the parts. So the analog voice band channel, the channel that is suitable for transmission of speech over analog data, that has the maximum usable frequency range from 300 Hz to 3500 Hz.